For reduction and oxidation reactions, to determine whether an element has been reduced or oxidized, you need to assign or identify oxidation states of elements to see if it has been reduced or oxidized. Just a little simple example here. So for example, these are elements where we are given the oxidation state. Iron goes from a +2 to a +3. We can see that it has lost an electron, so iron has been oxidized. So the value of being able to assign oxidation states, being able to determine where the electron is. An electron must have left this iron atom for it to become +3, and in chem speak, we call the loss of an electron oxidation or oxidized. Now, in this example, you're explicitly told what the oxidation state is. Here's a couple examples where you have to calculate it or determine the oxidation state of individual atoms. These are not complete reactions. These are compounds meant for practice to determine the oxidation state of individual atoms. There's a couple rules that are in here, outlined in the textbook and easily Googleable. But some of the rules are kind of, the first rule is that the sum of the individual elements must equal the total. Now the total, there's nothing written here, so the total equals 0. So all of the oxidation states must equal 0. Metals, especially alkaline and alkaline earth metals, are whatever oxidation state their column is. So for example, lithium is in the first column. Its oxidation state or common charge is +1. So lithium has a +1 oxidation state. Now, some of our rules for nitrogen and oxygen. Oxygen has either a -2 or a +2 oxidation state. Most examples is going to have a -2 oxidation state. When it is a member of an oxide, of a peroxide, where you have two oxygens bound together, it can have a -1 state. And if it's part of a compound called a superoxide, it can have a -1/2. But oxygen, for our purposes, is going to have a -2 or a -1 oxidation state here. This nitrate is not a superoxide or peroxide, so oxygen has a -2. All of them do. And that's a total of -6. We said that the first rule is that the sum of each individual must equal the total. There's no specific rules or guidelines for nitrogen. So nitrogen in this case, since everything has to equal up to 0, every nitrogen must be a +5 oxidation state. So let's do another example. Dihydrogen selenium. What is the oxidation state of each of the atoms that are present in here? Again, the sum of the individuals must equal the total. So there's no number written up here, so these sum must equal 0. Little rule for hydrogen. Hydrogen is either a +1 or a -1. Now, hydrogen is a +1 oxidation state when it is bound to a metal, and it is a -1 oxidation state when it is bound to a nonmetal. So what is hydrogen bound to in this example? Hydrogen is bound to a nonmetal. Based on this atom's location in the periodic table, you should be able to define whether it is a metal or a nonmetal. Therefore, hydrogen has a +1 oxidation state, and because there's dose of them, say it has a +2. So what must be selenium's oxidation state? If the sum has to equal 0, thank you.